First of all, I want to thank everybody for taking time out of their busy schedules to view this webinar. We've had some very, very, very positive feedback over the years on the information that we present here, that is presented here by Howard. The one thing that I do find a common theme is the fact that most people don't just view this thing once. There's so much information in this webinar that I will typically see the same names come across a few times with the hopes of them being able to get different various nuggets of information by watching it multiple times. For those of you who don't know me, my name is Jason Spangler. I'm the division manager here for flooring, responsible for not only the Rapid RH side of things from a concrete moisture testing standpoint, but I'm also responsible for the small line of wood hand meters that we manufacture for testing finished wood products, finished wood flooring, engineered flooring, and wood subfloors. We're going to go through a Q&A section here in just a few minutes. If anybody does have any questions, please email them. I will say if for some reason I can't get to everybody's questions, keep them coming. I will definitely respond to them via email. And if for some reason down the road you do come up with some questions, please feel free to reach out and contact me directly. My phone number is 800-634-9961, and my direct extension is 235. So without any further ado, one of the common questions I get is that in watching this video, Howard obviously makes numerous comments or alludes to the fact that the measurement for relative humidity is very depth specific. Well, obviously with a depth specific measurement, you have to have an overall thickness to work off of initially to be able to come up with a 40% calculation or a 20% calculation. Having that overall thickness from the beginning obviously is critical, or as close as possible. So there's a few different ways. Depending on how often you're doing the testing, how many tests you do in a year, they do make devices for being able to, with an instrument, being able to measure the thickness of the slab non-invasively. The product that I'm referring to it's based off of what they call an echo impact technology, and it's able to be placed on the surface of the concrete. It's actually connected to a tablet type device, and it will send these waves through and then give an assessment of the overall thickness of the slab. It's within a plus or minus. Obviously, it's not going to be an absolute, but it does seem to do a very, very good job from what I've seen. Downside to it, it tends to be fairly expensive for most people. Last time I saw it was in excess of $2,000. So if you're not going to be able to use it a lot, obviously it's not very practical for most. When you're looking at options other than that, I tell people that it's amazing when you actually are knowing that you need to know what the thickness of the concrete is. It's amazing when you go onto a job how many different tells there are on those jobs. Again, before doing relative humidity testing, most people probably didn't have to even think about the thickness of the slab because they were installing on top of the slab. That's all they cared about. So when you go onto a job on a rehab or some other type of renovation, you could potentially have a situation where there's trenching going on because they're moving electrical or they're moving plumbing or they're moving something along those lines. Obviously, you have the ability at that point, if the trench is open, to see what the thickness is. If you're looking at elevated slabs in a renovation situation, a lot of times in the access stairwells, a lot of times in the areas where there are penetrations coming through those slabs, they do a hole greater than the size of whatever that penetration is that's coming through. So you can actually see around the pipe or whatever's coming through the floor and be able to get a determination of what the thickness of the slab is. Another way that people are doing it that I hear about a lot is that they're taking a smaller diameter drill bit and they're picking a few places, usually on this end of the building or this end of the building or something along those lines, to be able to get a comparative measurement. And so what they're doing is they're taking the smaller diameter drill bit, they're drilling all the way through the slab in a couple of select spots. They're taking a piece of pliable wire, making like a J hook out of it so that the J is just a little bit bigger than the hole. They're pushing it down so that when they push it down, it collapses the J a little bit as they push it all the way through. The J, when it goes out the bottom or down through the bottom of the slab, will spring back out. So when you pull it back up, there's resistance. You can pull it back up until you feel resistance. Take a Sharpie on it, pull it the rest of the way out. Now you have a Sharpie mark and you're able to see a partial area where the radius for the J was at. And it gives you a fairly good measurement of what the thickness of that hole was. Comparing that in a couple of different areas gives you the ability to see if there's any radical differences there between, you know, one end of the area and the other end. Is it a perfect science? No, but at that point you've done your due diligence, and at least you can document and you have the ability to say that you did verify. When you're talking elevated slabs, the first thing is that the ASTM standard does not call out elevated slabs specifically. And when I talk about elevated slabs, I'm talking about concrete that's poured in pan decking. Because with pan decking, you end up with two different variables as far as the thickness. You have one area that's a overall thickness, and you have another area within the small segment that is a shallow thickness. So you have a deep thickness and a shallow thickness, and it alternates. So again, ASTM standard is completely silent on where to place. Do you place it in the shallow? Do you place it in the deep? Do you do it based on 20% or based on the 40% calculation in the shallow or 40% calculation in the deep? The one thing I can say is that most people will tell you that concrete in pan decking, no matter what the thickness is, you're doing a 40% calculation because there is not enough airflow on the bottom side of the pan decking for it to be drying from the bottom side. So it's only drying from the top side. So where are people placing this, or what thickness are they actually depending on? One way that people are doing it, we recommend that you actually look at the thickest portion and use that as your basis for the overall thickness of the slab, and that you try to identify where that thickest section is. So you're going to find that area that is, say, 5 inches deep, and calculate 40% of that 5-inch thickness and place your sensor in that area. So then the question becomes, how do I do that? Some people will take a smaller diameter drill bit and they'll do a few different holes to try to isolate where they are on the downhill side of the metal. Other people, and once you do that, you can isolate the center and then measure if you want. Other people are buying what I would classify a fairly inexpensive tool. It's actually a metal detector that works a lot like a wood stud finder, looks a lot like a wood stud finder, but it works to identify metal. And so what you do is you take it and you scan it across the concrete, the surface of the concrete, and the signal from the metal detector will be deep, or will be strong enough that it'll pick up where the high parts of the metal are at, but not so deep or not so strong that it picks up the deeper sections. So you can scan across, pick up the high spot, mark it, scan across, pick up the high spot, mark it, and then you know in the middle is where the deepest section's at. Again, in this situation, you could also use that other device that I was talking about that works off of Echo Impact if that $2,000 plus price tag doesn't scare you. What I will say about the metal detector is it's not going to be an absolute. There is potentially some rebar, there's potentially conduit, things like that that may alter, where the metal's at and the signal and what your readings are. But a lot of people have used it very effectively. All right, well, it looks like that's the end of our questions. Again, if there's anything else that we can do for you, please don't hesitate to contact us. My name is Jason Spangler. My direct contact information is 800-634-9961, extension 235. Thanks, and have a great day.